All right, so till here, you know signaling and you know connecting. Now let's go into the securing phase of WebRTC. Okay. Now this is going to be very, interesting how the securing part works. Okay. So for that, we have already seen that WebRTC uses DTLS. Okay. So DTLS is nothing but D plus TLS. Understand it like this. Okay. We already know the TLS part. So if you don't know what is TLS, it's very simple. If you know HTTP and HTTPS, right? So HTTP is nothing but the plain hypertext transfer protocol, and when you want to make it secure at the transport layer, you use this TLS. Okay, this protocol, and together this, along with TLS, the HTTP becomes the HTTPS. So this HTTPS is nothing but HTTP plus TLS. Similarly, for DTLS, it's nothing but, in case of HTTP, you use TCP, right? You use TCP at transport layer. So on the transport layer, if you use UDP instead of TCP, if you use UDP, it becomes DTLS. Okay. So DTLS is nothing but UDP plus TLS. Okay. So this makes DTLS. Okay. Now, what happens in case of WebRTC is, okay, so till this point, we have done the signaling with offer answer, and then we understood the ICE, and the using the ICE connection is established. All right. After establishing the connection, okay, the securing phase will start. Okay. In that securing phase, what happens from the one side, whichever is the controller side, now TLS or DTLS, okay, from here it will do what it will do. It will start the handshake. Okay, because it's TLS. If you understand TLS, how it works, it does a three-way handshake, and using that handshake, what it does, it creates a public and private key. Okay, public and private keys it creates. Along with that, it creates a certificate. Okay, certificate is created to identify it is nothing but the identity. Okay, identity of each side. Okay, so for peer 1, this certificate will mean, okay, this is the peer 1 only. Okay, it's like your certificate, it's like your Aadhaar card if you're in India. Okay, or any your driving license, it tells you like, okay, this is you. Okay, using those certificates you can identify yourself. Okay, so it creates this public and private keys and the certificate. Okay, so once this keys are created in the handshake, okay, so suppose the handshake happened, okay, and those keys were created. Okay, so after creating those keys, the keys will be exchanged. Okay, private keys will be kept one side, but whoever created this pair, they'll keep the private key with them and send the public key to the other side. Okay, similarly from this side also it will happen. And then what is the use of this certificate? Okay, this certificate will be used. Okay, this certificate will be created and it will be hashed. Okay, hashed means, if you don't know what is hash, it's just encryption. Okay, it's in one-way encryption. You have encrypted it, you can't decrypt it. Okay, you just hash it, and then it will generate some, it will look some random numbers and alphabets, just like UUID. I mean, not UUID, it will be like something similar, right? So it will create a string. Okay, and then that same string will be compared with the initial session description, where in the session description, when you create it, there will be one fingerprint. Okay, it will have the ICE fingerprint. Let me show you quickly. Okay, this is the fingerprint. This is the fingerprint that gets generated. This is nothing but the SDP. Okay, I was talking about SDP session description and all. So this is nothing but that session description. Okay, this is the offer. Okay, this is how it looks. Okay, we'll see, we'll come back to this and we'll see everything about this. Okay, so this is the fingerprint that gets generated, and this is the ICE password. This is the ICE this is ICE option. Again, we'll discuss about the ICE trickling phase also. I think I missed to explain the ICE trickling. So this ICE trickling is nothing but, you gather ICE candidates once you have shared the offer. So in this offer, you won't see the ICE candidates. Okay, so this is the fingerprint that I was talking about. And see here, ICE is again authenticated protocol. Okay, so here again you get this username. This is nothing but user fragment, ICE user fragment, and ICE password. Okay, using this, again, the ICE request, not ICE request, for ICE the request is stun request and response. Okay, for the connecting phase. So in the previous tutorial, we learned that this connection, after gathering those ICE candidates, the connectivity checks happens. Okay, so how that happens, they send the stun request. Okay, the stun request and a stun response, that's how they check the connection. Okay, and those request and response are authenticated using these username and password. Okay, all right. And this fingerprint, that is nothing but, okay, when this exchange happens, that fingerprint is compared with this certificate's hashed value. Okay, to make sure the exchange happened between these two peers only. Okay, the legitimate ones only, just to make sure. Okay, so this is another layer of security. Okay, so in case of DTLS, this public private keys will be generated and the certificate will be generated. Those certificates hashed value will be compared to that fingerprint which was generated initially here in the SDP. Okay, and using that exchange of public keys, your connection is now secured. Okay, because whatever happens after this part will be, whatever data exchange happens after that will be encrypted using these public keys, and the other side will be able to decrypt it using these private keys. Okay, so that's how security part works. That's how this securing phase works. All it does is uses this DTLS to do the handshake and creates the keys. Okay, so till here securing phase is completed. Now let's understand the communicating part. Okay,